is halogen exchange method. The name itself implies halogen exchange. The halogen atom is exchanged between the two reactant molecules. In this reaction, these two are the reactants. This is halogen of this molecule, this is halogen of this molecule. This is sodium iodide, iodo is the halogen. Here chloro and bromo is the halogen, Rx and sodium I. So these two molecules exchange their halogens. That is, X becomes I becomes X. These are the products we get. So in this reaction, here this is R is a hydrocarbon, that is alkane derivative hydrocarbon. X is either chlorine or Br, sodium iodide. This reaction takes place in acetone, liquid acetone, solution of acetone. So in the solution state, the reaction is taking place. It is soluble in acetone, it is soluble in acetone. These molecules act on this, forming this and this. After the reaction, the byproduct is sodium chloride or sodium bromide. It is insoluble in acetone. Therefore, it is precipitated as sodium chloride or sodium bromide. Look at that, the forward reaction is halogen exchange. Even backward reaction is also halogen exchange. But forward reaction is possible, spontaneous, feasible. What is the reason for feasibility of this forward reaction? It is the acetone liquid you are using, and this compound what you are using, and this compound what is forming. It is a property on which it depends. Look at that, the property of this sodium chloride or sodium bromide and property of the sodium iodide. The ionic character, the bond between these two atoms is more ionic in this direction and less covalent. Reverse direction, less ionic, more covalent. So here this is more covalent, less ionic. This item, less covalent, more ionic. Look at the difference. More ionic, less ionic, covalent. So bond is covalent. Usually these covalent compounds, whether inorganic or organic, soluble in what is that acetone like this, is a non-polar solvent or covalent molecules, non-polar solvent. So other way, these ionic substances are soluble more in what is that polar solvents like water. But this acetone is not a polar, it is a non-polar. That is why sodium hydride is highly soluble in acetone. But sodium chloride or sodium bromide, what you get now, it is less soluble, get precipitated out. That is why after the reaction, that substance now byproduct itself come out of the reacting system. That is, itself is coming out of the reacting system is solution as a precipitate. No possibility of involving again back into the reaction. And one more point, that is sodium iodide is more reactive than this. Sodium iodide is more reactive than sodium chloride and sodium bromide. So this is possible, feasibility forward reaction is more feasible. So this acts on this, forming this compound and is precipitated. This is called as it is found by Finkelstein. We call Finkelstein reaction. And it all depends on what is that forward reaction. It is based on what is that this compound and acetone. And this reaction is used exclusively for making iodo derivative of haloalkane. Here examples are, here this is generalized equation. The examples are R is, that is ethyl. Here the R is benzyl. This is aromatic group, but this carbon is what is that alkane carbon. This is alkane carbon. alkane carbon. So this Cl and Br derivative change into iodo derivative, corresponding iodo derivative because action of this in acetone. The byproduct is NaCl and Br. NaBr precipitated. These are the reactions. It is only for preparation of iodide derivatives. In the other halogen exchange method, let us see that what is that the reagents. Here the similar reagent, that is compound, the reactant remains same as here Rx. The X stands for Cl and Br, chloro and bromo. Here the reagent is different. In place of Na I am using AgF. What is Ag? A heavy metal. Fluoride, that is a fluoro derivative, fluoride of heavy metal. So the reagent can be this or two more reagents are there. That is mercury fluoride, Hb2F2, and antimony trifluoride, SbF3. These are heavy metals. So fluoride of heavy metal is used as a reagent in this reaction. Here also the same kind of reaction takes place. Halogen exchange. So there, what is that? These halogens are exchanged between the two molecules. So this is fluoro or bromo, this is fluoro. After that, what is that? You get the product like this. RF, fluoro derivative of alkane, and AgX precipitated as AgCl or AgBr. And the property is similar to this. The ionic property of this compound is same as this. But the reaction is not taking place any media like this. So direct mixing. This is usually a solid substances. These are solid substances. This solid substance and this organic compound, that is again haloalkane of chloro and bromine derivative. It may be liquid or gas. Small molecules will be gaseous state and bigger molecules are liquid state. So the direct mixing, what is that? Direct action gives this product. And reason for forward reaction, the possible, that is feasibility of forward reaction, it is based on this property. Look at that, this bond and this bond. That is AgCl or AgBr. This bond is stronger, this bond is weaker. It is between metal and this fluid. So stronger bond is more stable, weaker bond less stable, more reactive. It can act on this, reactive, less stable. So forming this compound more stable. That is the reason for what is that? The feasibility or spontaneity in the forward direction. Therefore, this is possible. So this reaction is, look at that, F exclusively for the preparation of fluoro derivative of haloalkanes. So it is called Schwarz reaction. The reagents are any one of them you can use. Here are some examples here given. It is chloro of methane, chloro derivative of methane, ethyl bromide, and here this is aromatic hydrocarbon, but this carbon is halogen. What is that? Halogen carbon is that is alkane carbon. That is alkane carbon with Cl3. It is alkane. Alkane connected to aromatic. But reaction is here, it becomes haloalkane group. So this is Cl3, this is Br. Replaces, this can be replaced by F using this reagent or this reagent or this reagent. Same reaction. F corresponding reaction byproduct of AgCl. If Cl is there, Br means corresponding bromide. It is silver bromide. It is antimony chloride. All fluorine atoms are replaced by fluorine. That is derivative of F, fluoro derivative. These fluoro derivatives are called as freons in organic chemistry. These are finds usually they have more applications. A lot of applications are there, but highly toxic, highly harmful substances. These substances. So this is how this reaction used exclusively for the preparation of fluoro derivative, the reagent. comes under halogen exchange method. So there are two methods, halogen exchange methods. Using this, we can go for preparation of hydro derivative. You go for preparation of fluoro derivative. And one more reaction that is there. That is this reaction. This reaction is called as Huns-Decker reaction. Huns-Decker reaction. In this reaction, what is the chemical reaction of this? Look at this compound is organic compound, silver salt of carboxylate. This is carboxylic group, or there is hydrocarbon, there is other part. That is, if H is there in place of G, it becomes carboxylic acid or organic acid. If you replace that H by GH, it becomes salt. What salt? Silver salt of carboxylate. That is, carboxylic acid is carboxylate. Silver carboxylate. So this is acted upon by bromine in presence of Cl, that is carbon tetrachloride solvent. We get the product, that is bromo derivative of this alkane. This is eliminated, removed as carbon dioxide. That is, carbon chain is degraded, descent. So near AgBr. So using this reaction, we go for preparation of bromo derivative. That is general equation, bromo derivative. So this is Huns-Decker reaction exclusively for preparation of bromo derivative. So example, your reagent is this bromine. The solution of bromine in CCl4 is the reagent. Example is this CH3COO, that is acetic acid derivative. So silver acetate, silver propionic acid. Br gives corresponding bromide derivative. Carbon dioxide is removed. AgBr is a byproduct. In this reaction, what is the reaction mechanism involved in this Huns-Decker reaction? The first step is, what is that? Is action of bromine on this. That is what. Here, breaking chemical bond between them, breaking what is that, forming the corresponding, what is the bromo derivative, AgBr and bromo derivative is. Still carboxylate group is there. This undergoes what is a free radical mechanism in presence of CCl4, symmetric breaking. Br and RCOO, free radicals are obtained here in presence of CCl4. And this free radical is highly unstable. It is getting decomposed into carbon dioxide and another free radical R. This free radical and this free radical combine to give this and this give RB. What is it? RBR, that is bromo derivative of alkane. This is the mechanism in brief. So all these reactions are very important in organic chemistry. That is the one used for preparation of iodine derivative. It is for the preparation of fluoro derivative. It is for the preparation of bromo derivative, exclusively for this reaction. So this is one just minute. And let us move on to the examination corner. In this examination corner, here these are the examples. These examples may be important for the competitive examination as well as the annual examination. Look at that, I am using symbol. Let us understand what is the symbol, because in the symbols we don't write carbon, hydrogen present in that. Any other atom other than carbon is indicated here. Look at this, the lines and this vertex. Usually this line end, that means CH3 is there, because this is bonding. There must be carbon, other one bond is there. There must be 3 remaining bonds must be with hydrogen atom, that is CH3. This end is containing CH3. What about this vertex? Carbon, already we have 3 bonds. There must be one more bond bonding with hydrogen, that is CH is there at this vertex. And one more end, that is end is carbon, Already we have two bonds. Remaining two bonds are with hydrogen. That is CH2. Here CH2 is present. CH is there. CH3. Carbon and hydrogen are not indicated. Only lines like this. So this is a reactant. So on this reactant substance, this is action. This is action of this mixture. HBr in peroxide, that is benzyl peroxide, and HCl in benzyl peroxide. Look at the difference. This usually what is that in presence of this peroxide undergoes anti-Marconi Cox rule. It takes place only in case of HBr, not in case of HCl. I'll tell you the reason. What is Marconi Cox rule? That is addition of HBr and HCl. No, the unsymmetric double bond. The double bond is unsymmetric. To this HBr is added, unsymmetric molecule is added. Usually the hydrogen to carbon containing more number of hydrogen, that is Marconi Cox rule, and bromine to carbon containing less number of hydrogen, that is Marconi Cox rule. What is anti-Marconi Cox rule? Reverse addition. Anti-Marconi means hydrogen to carbon with less number of hydrogen, bromine or halogen to carbon with more number of hydrogen. Reverse is anti-Marconi Cox rule. Here this undergoes anti-Marconi Cox rule. Even in presence of this, no anti-Marconi, directly it takes place Marconi Cox rule. Marconi Cox rule means the halogen to carbon containing less number of hydrogen. There is one hydrogen, there are two hydrogen. Addition is over here. H is added here, Cl is added here. Carbon with CH. Here CH3 is understood. CH3 is there, CH2. It is Marconi Cox addition. But here, what is that? Anti-Marconic. This Br is bonded to carbon with what is that? Less number of hydrogen. Here, Br connected to carbon and hydrogen to this carbon. This is anti-Marconi Cox rule. Why this HBr? The reason here, among HBr and HCl, the reactivity difference. Look at the reactivity. This is the order of reactivity. This is more reactive than this. This is less reactive than this. So whichever is more reactive, which will what is that? Go for what is that? Preference for the reactivity than selectivity. So there are two types of concepts in organic chemistry: selectivity and reactivity. Selectivity depends on the type of carbon to which the halogen is forming bond. That is, type of carbon is tertiary carbon, secondary carbon, primary carbon on the basis. Selectivity. So either go for the addition is, substitution is, the bond formation you go for either selectivity or reactivity. Reactivity means if the reagent is more reactive, that is like this will go for what is that? Prefer reactivity than selectivity. Will not select what is that? This carbon is what is that? More stable, that is, it is secondary carbon, it is primary carbon among this. So therefore HBr what is that? Violates, that is that because of reactivity it violates, reverses, not go for selectivity, reactivity. This reactivity is further enhanced by this presence of this peroxide. That is why. Already reactive, it is supported by this peroxide. This is less reactive, even though support is there, not go for reactivity, it go for selectivity like this. Selectivity means second carbon, not second primary carbon. That is why it undergoes Marconi Cox rule even in presence of peroxide. Anti-Marconi Cox rule. And second example, similar, what is that? Depends on the Marconi Cox. The same asymmetric alkene. Here open chain, it is closed chain. Alkane, cyclic alkene here. Is again asymmetric alkene, not symmetric alkene. So let us understand the carbon hydrogen present. This is vertex. Carbon is there, two bonds already there, remaining two bonds with hydrogen, that is CH2 is here. Similarly we have CH2, CH2, CH2. This vertex C two bonds, three bonds, already three bonds, one more bond with hydrogen, that is CH is here. What about carbon at this vertex? Look at this, C, 1, 2, 3, 4, 4 bonds are there, already satisfied, no hydrogen, it is only C is there. Carbon with no hydrogen, carbon with one hydrogen, unsymmetric alkane. Look at that, let us go for what is that action of these reagents, HBr, HCl, and this reagent and this reagent. What do you get? Marconic oxidation or anti-Marconic oxidation? So anti-Marconic oxidation means here the what is that halogen atom either Cl or O, they are will select this carbon because this carbon is tertiary carbon. Is that no hydrogen or less hydrogen, no hydrogen. So this bonding with this and hydrogen is this. So this hydrogen is added. This is CH2. CH becomes CH2 like this. Cl is here. This is Marconic of addition. HCl, HBr without peroxide. Same addition. Marconic of addition. And HCl with peroxide. Same addition. Marconic just like this. Marconic of addition. But here HBr with peroxide. Opposite addition. Here Br. Here H. So this is what is that C. This end is CH3 is here. Always end of line is CH3. This is C. So this addition is Marconic of. This is Marconic of. This is Marconic of. This is anti-Marconic of. Look at the differences. This examples. The object any type of question they can ask. Say anyone like this, anyone like this. All the four are combined together like this. So the reactant is this, and if this is the reagent is this is the reagent, this is the reagent. Look at the products what you get. Marconic capsule and anti-Marconic capsules. That is the second one. Third one, that is aromatic hydrocarbon, not cyclic alkane. That is alternate double bonds are there. Here OH is phenolic group. CH2OH. It is alcoholic group because this OH is to alkane type. It is carbon is alkane. It is aromatic. So to aromatic is all phenyl. It is alcohol. Alcohol action of HCl or ZNC. That is just like HCl ZN2 or HCl heating that you get this. Replacing OH by this. Nucleophilic substitution. You get chloro derivative. Not this one. Alkane carbon, not from the aromatic carbon. This reaction is possible. And another example, look at this compound is aromatic compound again is a nitro compound. Here nitro group is there, MO2, and here CH2, CH3 alkane group is there. So by the action of bromine in sunlight, usually the halogen in sunlight will act only on the alkane derivative, not on the aromatic derivative. That is alkane, CH2, CH3. So what happens here? The Br to this carbon or this carbon? Br to this carbon, not this carbon. The reason here, this carbon is selective. You know what is Br? Among this Br and Cl2. Okay, that? Among this, no, this is less reactive, this is more reactive. That is, Br2 is less reactive. You will go for what is that? Selective. Prefer selectivity, not reactivity. Br2. Here I am talking about Br2 Cl2, not HBr like HCl. So this carbon is secondary carbon that is connected to this. And this carbon now during formation it forms free radical mechanism. This free radical carbon is stabilized because of secondary carbon as well as a resonance effect of the benzene. Alternate double bond is there. That carbon radical is further stabilized by the resonance. This move along this double bond now. Bonding electrons are moving this also is involved in the delocalization of this. Further stabilizes for the formation of this compound like this. Therefore, this is correct and Br substitution of this carbon is not correct. Correct compound is this. And next is, it is not benzene. Then cyclic compound, cyclohexane with alkene, symmetric alkene. Br addition, symmetric. You get what is that? Vicinal dihalide. dibromo to this. Br to this carbon, Br to this carbon, very effect of it. It is cyclic compound, alkane compound, addition of bromine to alkene, that is double bond, pi bond, just addition like this. And the last one, look at this compound. Here CH3 is there. C already 3 bonds, one H, CH. This vertex is CH, this end is CH3, and this vertex is C. Already 3 bonds are there, CH. This end is CH2, 2 bonds. That is alkene, propanol. So that is asymmetric. Again, same kind of what is that? Asymmetric carbon. That is again carbonic oxide. Symmetric alkene addition of HBr. So here we look at that Br to this, H to this. We expect this. But finally we get this compound because look at this carbon. This carbon is secondary, this carbon is tertiary. During the formation of carbocation here, before the addition of Br, undergoes further rearrangement. That is, this hydrogen is shifting from here, and this carbon, instead of forming this carbocation, here carbocation is forming during rearrangement. Then the Br is added. So first is Markovnikov's assumption, and again go for selectivity. That is, which carbon is more stable. That is, this carbon is tertiary carbon, this carbon is second. This is finally shifting. Then carbocation we find addition. We give this compound. This is the correct compound on this compound. These are the examples you should expect in the examination. Thank you.